First of all, thank you all for coming. This is a really fun opportunity for me. I really do love teaching this stuff, and I especially love the idea of humanities and humanities adjacent scholars getting involved in programming more generally. And Python is a very simple way of getting involved with kind of a low commitment level required early on. So it's a good place to start. This particular session is going to be essentially aimed at absolute beginners. So if anybody is coming in with slightly more knowledge about how to program, which does translate into Python, even if it's a different language, or those who are coming in with some Python experience, we are beginning at the absolute beginner just to make sure everybody is on the same page. We'll be having essentially 4 sessions, 2 today and 2 tomorrow, with a little 5-minute break in between. It's really important that you take the 5-minute break. This is going to use parts of your brain that you don't normally use walking around the house or talking with other people. So you need to give yourself a chance to decompress before you come back in for the second half. If anybody has any technical problems going forward, I have tried to create ways around that, but we won't abandon you. We will try to keep you coming along. So there's 2 places that we'll need to go today. The first one is the Jupyter notebook instance that we're going to be using, which is available from CoalCalc.com. Now, this particular website essentially runs an instance or a web browser version that's server side, which means it's running Jupyter Notebook on its computer server rather than on yours. Outside of this session, or in between these sessions, you are very, very welcome to download a copy of Jupyter Notebook for your own computer, so you can do this offline. But for ease of installation, and because I know there's a variety of Linux, Mac, Windows, just to kind of cut down on the technical side, I am going to suggest that you use the browser version for today and tomorrow. It also has all the extra libraries that we're going to use tomorrow already installed, so you don't have to worry about that. But that being said, let me just give you my 2 cents about Python and programming in the humanities. Believe it or not, the first few things I did were PHP, which is kind of like web functions, XSLT, which was turning my XML files into other kinds of files, and a little bit of C. So when I started learning Python, I had kind of a way of thinking about it already in my head. That being said, I am first and foremost a humanities scholar. I'm a historian by training. I did history all the way through from, undergraduate, MA and postgraduate, with a little bit of theater and English in my undergraduate days. So when I write code, when I write programs, they do have a humanities flair to them, apparently, according to computer scientists. And so I want you to kind of take that on board, that there is no one perfect way to write code. There are lots of tricks to make it more efficient, to make it run faster. If you have computer science friends, they will definitely teach you those tricks. But here, I want you to understand that your research that you do in the arts and the humanities can be translated into tools that you can create that do exactly what you need them to do from a humanities perspective. And that's what I think is so important. You know your subjects better than any computer scientist, no matter how good they are at programming. And you can write your own programs that do exactly what you need it to do and have the assumptions that you need them to make to get the kind of research that you need. That'll make more sense going forward, but hopefully it's a nice introduction. So I'm going to share my screen now. And I'm going to walk you through. So if you have a desktop or a big enough screen that allows you to have my window and your Explorer window or your Firefox window both on the screen at the same time, that's probably going to be the best way for you to proceed. Otherwise, you're going to have to be flicking back and forth quite a lot. So here is hopefully a full screen of the CoalCalc website. Okay, so as I said before, this is a website that kind of runs these on their own server. You do have the ability to sign in if you want, and you can sign in with, Google, GitHub, Facebook, I think, a couple of other ones. But you don't need to do that today. It's just if you want to save your files and not lose them, you can do that with one of their single sign-in options. But I'm just going to hit Run Jupyter now. And this is almost exactly the same as if you run it on your own computer, so it should translate quite nicely. And I'm going to create a new program, a new project. I'm going to call it Python for, sorry. I'm going to hit this, sorry, welcome to CoalCalc, and then I'm going to hit new. And then you can call it whatever you want, but I'm going to call it Humanities. And I'm going to make it a Jupyter notebook. So just to kind of refresh where we are, go to the Welcome to CoalCalc, create a new program, and make sure that it is a Jupyter notebook. It will take a moment to load up, and it'll say, what do you want? And you want it to be Python 3. As you can see, those of you who like R, you can do R notebooks this way as well, but we want Python 3. Okay, so now we have hopefully a blank Jupyter notebook. Now, let me give a little bit of a background on Jupyter Notebook versus Python more broadly. Python is a language that you can write into individual files called Python files, .py, and you can run those using a Python interpreter on your computer. However, Jupyter Notebooks are essentially a way of documenting what you are doing while you are running code. So if I go to this first line and I change the code to Markdown, which is basically just, you can write LaTeX or Markdown text, just plain text if you want. This function is going to do something fun. And then I can hit run, and that saves it. So that is basically just a text. That does nothing, it just gives documentation. And that's really useful for anything that you are writing code for, so that you can go back and say, what is this doing? Why did I do it this way? What does all of this mean? It lets you essentially document it as you go along. It also lets you run it in the editor. So if I type something in, like that, and then run it, it will automatically run the code for me. And it says hello world because I told it to. If you were doing this with a normal Python file, you would have to close down the editor in which you wrote this and then run the Python file with the Python interpreter, which means every time you made a little mistake or every time you wanted to go back and test something or change it, you'd have to reopen it, re-edit it, and then rerun it. Because this all sort of inside this editor, you can constantly just kind of fiddle with it to get it to work well, which is why it's kind of ideal for this teaching session. So the first thing we're going to do is we're going to do the first thing that everyone has to do anytime that you do any kind of Python. I want you to do the hello world as well. So the first command that you need to learn in Python is print. Now, print is basically telling it to, on the command prompt, on whatever window you're running this Python file in, I want you to print something to the screen, and I want it to be some sort of text. And the thing that you want to print needs to be in these parentheses, as Americans call them, or brackets, as I am told the British call them. And it can be one of two things. It can be a variable, or it can be a string. And we're going to start with a string. So all strings just go into either double quotation marks or single quotation marks. It does not matter with Python, but you have to be consistent. And then whatever you want it to say. So in this case, hello world, and then hit run. If you're using a Windows machine, you can also hit Control Enter, and that will run it as well. So the first thing I want you to learn how to do is to create a variable. Now, as I said before, and for those of you who have done some programming beforehand, variables are essentially boxes or they're placeholders for things you want to do. If you can remember back to school with basic algebra, the most common variable you used was x. X does this, and then you stick a 2 or a 4 or a 7 or whatever you want into that variable. There are lots of different kinds of variables in Python, and we're just going to talk about a couple of those right now. So I'm going to just put this in here. Again, I'm going to make this in my documentation. Okay. So the 4 or 5 different types of variables that you're most likely going to be using are strings, bools, ints, and floats. And for today, we are going to concentrate mostly on strings and ints, but I'm just going to talk about what they are first of all. Strings are a string of letters, numbers, or other characters. They're also called literals. They're basically anything that goes into the quotation marks, just like in a search engine, will come out exactly the way you put it in. So if you want to use more than one letter, or if you want to use a combination of letters or symbols, that's what you use a string for. It's basically the catch-all for all of these things. A bool is named after Boolean logic, and it can only have one of 2 values, which is true or false. And I've made this a little bit confusing, so I'll fix that. 1 is for true and 0 is for false. Or you can write the word true and false without quotation marks, but with capital letters, and that will work as well. And don't worry if you're not remembering all of this, we'll be using them quite a lot. Int is short for integers, and that is basically any whole number, whether it's positive or negative. Longs are really, really big numbers. We won't really probably be using those today. And floats are for floating point values, such as 3.14. So anything with a decimal point. And Python is user-friendly in a lot of ways, in that if you say something is, quote, the, end quote, it kind of assumes it's a string. If you type in the number 4, it assumes it's an integer. If you type in 3.3, it assumes it's a float. If you don't want it to be the thing it's most likely going to assume, or you want to use a string of 3.14, you do sometimes have to kind of prod it to make sure that it knows what thing you actually want, because you can only apply certain functions on certain types of things. So for example, if you have an integer, you can add and subtract and multiply integers because they're numbers. They allow you to do that. But if you have a string, like the word the, you can't subtract the word is from the word the. It doesn't know how to do that. So it's important that Python knows whether or not you're talking about a string or an integer or a float at any given time. So what I'd like you to do is I would like you to make a couple of different variables. So when you want to assign a variable, you're basically creating a lookup table somewhere that says, when I say this variable, what I really mean is this other thing. So for example, if you put my name, and variables have to be a single phrase, they can't have any spaces. If you want spaces, you can use underscores if that makes it easier for you to read. So my name equals, and this is really difficult for a lot of people to remember when they're going into programming. Equals is actually a symbol that means a sign. So it doesn't really mean equals in the way that you would with mathematics. It means I am assigning something to it. So my name is being assigned the value of Melodee. And I'm going to do another couple of variables as well. So my integer is going to be 4, and my bool is going to be false, again, with a capital letter. Now, if you look at these, you can see that Jupyter Notebook has done something really helpful in that it has color-coded the different types of variables that I've created. So Melodee is a string, so it's put that in red. My int is an integer, so 4 is in green. And the Boolean is purple because it's a Boolean. If I had made this true, it would still be purple. But if I typed true without the capital T, it doesn't know what it is. It's like, what are you doing with that? And what this is actually saying is go find the variable true, which I've not created, and then assign bool to have the same value as whatever variable true is. So you do want to make sure that your things that you're assigning are in the correct format. Now, once I've written those three out, all I do is hit run, and you can see absolutely nothing interesting happened. It just kind of said, I'm doing something, now what? What that's basically done is it's put all three of those variables in memory. So now if and I'll just put a couple of spaces here so I can move up. If I go to the next line, and you can add lines by hitting this plus button over here. If I go to the next line, I can print and ask it to tell me whatever my variable was. So if I go print, and I don't put in quotation marks Melodee because that's just telling it the actual literal thing to print. I give it a variable. So I type in my bool, for example. And if I run it, false, because that's what I had printed previously. So go ahead and take 30 seconds, 45 seconds, if you've not already, and go ahead and make yourself a couple of variables. Your name, your favorite number, and true or false. This is my first time doing a programming tutorial. And once you've made your variables, go ahead and try to print one or more of them out. As I said before, you can always go back and simply change what you've written, rerun it, and see that it's come up. Okay, that's wonderful. So what we'll do now is we'll do something with all of those lovely variables that we've created. Now, what you want to do is create a list, because we don't want to have to constantly be saying my name, my int, my bool, because maybe we just have a list of lots of people's names. So what we're going to do is we're going to create a list called about me, and we're going to make it filled with something. Now, a list is just a packaging, a container that contains multiple variables in it. And the nice thing about Python is that lists don't have to be homogeneous. Everything in your list doesn't have to be a string or ints or floats. It can be a combination of all sorts of things. Now, that's also dangerous because you have to remember what's in your list, but you're programming your own thing. So hopefully you'll have a system or a logic to it. But in this case, I'm going to make a list. And the way we make it a list is by using these square brackets. So again, normal brackets is for function commands, for print commands, but list come in these square brackets. Now I'm going to start just with that and make it its own thing, so you understand that you can create an empty list as well. You can have a list that has nothing in it. But in this case, I'm going to fill it with a couple of objects. And the way you fill it up with objects is either with values. So I'm going to say I am a researcher, or with variables. And you separate everything in the list with commas. So in this case, I am a researcher, and my name, and my int, and my bool. And if I run that, the about me list is now stored in memory. And I can actually go ahead and print about me in the same way I did everything else. And again, I get these 4 values that I've included. Okay, so hopefully that makes sense. It's important that we all have these lists. So go ahead and create your own list of variables, whether that's with just the 3 variables you did, or including a string or a number in there as well, just so that you can practice. And you don't have to rerun your variables box. It will stay in memory until you overwrite it or close down this window. What you've seen here is that you can print individual variables, and you can print an entire list that you've created. but you might want to use only one part of your list. So if I wanted to get the first item, okay, so once you have all of your information in a list, and don't worry, we won't go too fast ahead. Yes, so Control Enter does do that, or you can hit this run button here when your cursor is inside. Both of those should work. If you're using a Mac, I believe it's Command Enter, but I would err on the side of hitting the run button. So the next thing that we're going to want to do is to figure out where exactly our information is in this list. So if I print about me, it's going to print the entire list, but maybe I don't want the entire list. I just want the first value. So what you do is you have to explain to it that I only want part of it. And the way you do that is with square brackets. And the square brackets actually have a colon in it. And what you do is you put the first item that you want before the colon and the last item that you want at the end. So if you only want one item, you can just do the number on its own. It's pretty straightforward. And you said about me 1, so I'll do that. About me 1, hit run, and I get Melodee, which is not what I wanted. I wanted researcher, not Melodee. And that is because when we count in computer languages, we count from 0. So everything starts at 0. 0 is researcher, Melodee is 1, my int, which is the number 4, is 2, and false is 3. So if I go here and put in 0 instead, I get researcher, which is what I wanted to begin with. So that lets us get the information we want very, very easily. Now that we have the information we want, we can start playing around with it. Now, we're going to play around with the int in the first instance because it's a little bit simpler to get your head around Python operations with numbers. So again, we have our myInt, which is number 4, and we could call it myInt, but I think the way that I want to sort of get your head around it is to use the variable within the list. So about me 2 will get me the number 4. Now, just like any other mathematical equation that you've probably seen, you can actually do basic maths, including plus, minus, multiply, and divide with these different variables. So if I use about me plus 6, I should hopefully get the number 10. And I do. So in this way, I can update my work. So for example, if I look at about me dot 2 again, it still says 4. That's the original thing, because all I did is I asked it, what is about me 2 plus 6, not change it to a different number. So in this case, I want to change it. So again, I go back to about me 2 equals, I'm assigning something to that, and I want to do about me 2 plus 6. And I want to see if that worked. So I use print about me again. Now I'm moving a little bit fast here, but hopefully that makes sense. This is what I'm trying to change. So it's the thing that's being assigned to. This is the value I am changing it to. I could also just write the number 10 here, but this lets you see that I can actually take this value, about me 2, add 6, and then replace the original about me value 2 as that. So if I run it, you can now see that I've changed the list to actually have a different value there. So go ahead and have a quick play with yours in terms of multiplying, subtracting, dividing, anything like that. In terms of the space here, it absolutely doesn't make any difference. So if I had typed in about me 2 equals about me 2 divided by 2, print about me, it creates the exact same thing. So the space is really just about readability. It's important, however, that when you have these little brackets, however, you don't put a space before them. So making a list is with these square brackets here. So now that we've done this, you may have noticed that there is a 5.0 here rather than a 5. Now, the reason for that is what I said at the very beginning, which is Python is doing its best. And because I've used the division modifier, it said, oh, well, sometimes when you divide things, you get fractions, and I can't handle fractions. So I'm going to make this a float so that it will stay, so I won't lose any information by accident. Even though this is a whole number, it decided that to play it on the safe side, it was going to transform it into a float. Now I can actually make it do what I want and make it stay an int by saying that about me 2 equals about me 2. And if I put the whole thing in normal brackets and type in int, it will basically force it to be an integer rather than a float. And that's not something that's going to be that important for today, but it's good to know that if Python does something you don't expect or you don't want it to do, you can force it to behave, to act in the very specific way that you want to. Now, what we're going to do for the moment then is we're going to move on to one of these other terms that you used. Now, if you did your list the way I did, where I put my role and then my name. So again, I'm going to just start a little bit from scratch so that everyone can see what I'm doing right here, which is about me equals researcher. My name, my int, my bool. And then I am going to use the same operator of plus, but it means something very different to a string. So if I say about me 0 plus about me 1, and I run it, what it does for strings is it basically smushes them together. It creates one long string. Now, the reason it does this is because computers are very eager to please you and very helpful, but they're also very stupid. It does not know that those are two different words. In fact, it doesn't know that they're words at all. All it sees is a series of different characters. It sees a capital R, an E, an S, and it doesn't make any sense of them. Now, that can be really useful for humanities research because it helps us avoid biasing our results because it can't read it and make assumptions about what these words mean. However, in this case, we really do want it to say something more intelligible than researcher Melodee as one single phrase. So you can actually construct really interesting strings by using these plus operators. So if I say about me 1 plus, you can add in another string, is a plus about me 0. Now, I could just hit enter here. In fact, I will so that you can see it. And it creates, oh, I didn't put my extra spaces in. It creates a nice little phrase. Melodee is a researcher. And that's great, but I could have done that by just typing that all into a string. The power of the Python language is that these are variables. So instead of just doing this as a single one-off function to see what it is, I'm going to assign this as a variable. So my sentence equals this. And then if I change about me 1 to lecture and run it, so it's now changed what that variable is. And now I run my sentence. Oops. So whenever you get a name error, it means that it doesn't know what that variable is. And that's because I hadn't created it yet. Okay, so this did not work. Why did this not work? So it says Melodee is a researcher, but I've already changed about me from lecturer to researcher. You can see that I changed my own name to lecturer rather than researcher, but this sentence still says Melodee is a researcher. It actually should say lecturer is a researcher. Lecturer is not in my sentence. Absolutely perfect. Yes. So when I told my sentence to combine about me 1 is an about me 2, it didn't store those variables. It didn't store it as some kind of equation. It actually just made a string and saved the string as it existed at that particular moment. So if I want to update my sentence, I have to run this function again, where I reassign what my sentence is to include those new versions. And now it'll say Melodee is a lecturer. So the important thing to remember here is that if you go about assigning something to another variable, just because you update the original does not necessarily mean that it's going to automatically translate down. You have to tell it to do that. Now, again, that's because computers are willing but stupid things. They don't know what to do. They're just waiting for your instruction. They don't want to do something unless you've specifically told them to do it. What I would like for you to do is to create a set of instructions that are going to do a couple of things. So I'm going to write them out and leave them on the screen so you guys can see them. The first thing is I want you to create a list of, and I'm going to turn this to code so it doesn't, sorry. Okay. So a list of values, a second list of values in the same order. So for example, if I did lecture, Melodee, for false, I might do Professor Bob 3 and true, or something like that. Then I want you to create a print command that creates a sentence using values from both of those lists without having to write them out specifically. And I will give you all a minute to go ahead and do that. And you can do these in separate boxes if you wish, but it can be useful just to do them all in one box so that you are always running them every time it goes through. Okay, that's a really good question. So if I've done my list 1 equals A, B, C, and my list 2 equals D, E, F, and print my list 1, my list 2. What did I do wrong? Name error. Oh, they're variables. Thank you. Thank you very much. See, it doesn't matter how long you do this. You often just forget. There we go. Okay, so in this case, what it's done is it's printed this list and this. And that's because what it's basically said is run the print command on this one, comma basically says, now go ahead and print the write the print command on the second one. So it will do it this way. If you want to print everything together, you actually need to go like this, like that. Sorry, without this, and do the thing like that. They can make a table, but that is slightly more complicated, and it's not particularly useful for the program itself. The print command is really just about displaying things to give you basic information as opposed to full visualizations. So as you can see, doing this for all 6 variables is actually quite a lot of hassle. And the point of doing programming is not to make it more difficult, but to make it more straightforward. So we're going to learn something called the join command. What we'll be doing when we come back is we'll be learning ways to go through all the different elements of these strings in order to get them to automatically fill in and create more interesting objects than just having to say each variable individually, which you can do that in a word processor anyways. So to create a list of values, do we have to start with about me list? Okay, so I'll just bring my screen back up for a moment. Okay, so if you want to create a list, you can start with this, which creates a blank list, but you don't have to necessarily do that. You can just start with my other list equals this is a list. And that will do that. That's the only way at the moment that you're going to be able to create a list. We will do a more automatic way of doing it in the next half hour.